Hi, and welcome to Mike Likes Robots, where we share knowledge to accelerate robotics. And today I'm continuing the Advent of Code series with day 9. Today's puzzle is called Defragmenter. So I'm going to take a read through this, see what it's about, and then cut to the end where I can explain it. Okay, so our puzzle today is, on the surface, it looks like it's about array manipulation. So we're given a puzzle input like this one, although that's quite a difficult one to explain. A simpler one to explain is the disk map 1, 2, 3, 4, 5. And the puzzle does a pretty good job explaining this, so take a look at the link in the description if I don't do a good job, because it did take me reading this a couple of places a couple of times to figure out what was going on. So essentially we have number of blocks occupied, then number of free blocks, number of blocks occupied, number of free blocks. But on top of that, it goes from 0 to n, so the ID that is occupying that block. So in the example 1, 2, 3, 4, 5, yeah, here it is. So it's 1 block occupied, followed by 2 blocks of free space, followed by 3 blocks occupied, followed by 4 blocks of free space, followed by 5 blocks occupied. On top of that, the ID of the file is going from 0 to n. So it starts at 0, then it goes to 1, then it goes to 2. And then there's a slightly longer example, which gives us a much longer string. Then the puzzle says to move the file blocks one at a time from the end to the beginning or the leftmost free slot. Now, initially, the idea would be to actually create an array with free slots in it, maybe with options in, and then sum across that array once the process is completed. But I think there is a simpler way to do this. And the simpler way is to track from the start to the end. You would be able to add the digit on if the block is occupied from the start. And if you need a digit if there's a block of free space, then you iterate backwards from the end. So we don't do any array copies. We just have a fixed set of numbers that we've read out. And then we either take from the start or from the end, depending on how far through the block of memory we're defragmenting is. The reason we don't actually have to move it is because we then calculate a number based on this. So at first glance, I'm not entirely sure how to represent that with data structures. I'm sure we'll figure it out. So let's switch to VS Code, and I'll skip to once the project has been set up. Okay, and we're set up. So the first thing that I want to do is create some files to represent the examples that we've been given. This puzzle gives us 2 examples. So I'm going to take both of those. So I'll start with test small.txt, which will just be 1, 2, 3, 4, 5. Then there's test.txt, which is this number here. All right, then I'm going to set up my test suite, config test, mod tests, use super. Test small text. So we've got 1, 2, 3, 4, 5. The example gives us, well, actually it gives us the defragmented solution, but doesn't give us what that actual result is. So I'm going to take this, which is my string, and then I can either calculate it myself or get the program to calculate it. So that's 0, it's 2 plus 4 plus 3 plus 4 plus 5 plus 6 times 2 is 12 plus 7 times 2 is 14, 8 times 2 is 16. So I think it's that, and that would be 6 plus 3 is 9, plus 4 is 13, plus 5 is 18, plus 12 is 30, plus 14 is 44, plus 16 is 60. So I think the answer to this is 60. Now, if I start getting something reasonable sounding from my program that is above or below 60, I'll probably confirm that that's the right answer. But for now, I'm going to go ahead and assume that's correct. So let's read in the test small input. Let puzzle is include string. Oops. String from puzzle test small dot text. Now I'm going to do some operation on it. So let result is do something puzzle. Then I'm going to assert that the result is 60. I'm going to leave my working out here just in case. Okay, so that's some confirmation that I've got it set up correctly. Next thing I'm going to do is actually start parsing the puzzle input. So I'm going to create a struct. It will be my Defragmenter or defrag, I guess. And now this is the question because I said I wasn't sure what data structures to contain in it. So I'm going to have a guess, and then I'm going to try and write the algorithm and update the data structure if it turns out to not have the information I need in it. So this will be, I'm really not sure. Let's just start with pairs of numbers. That seems simple enough. Okay, that's going to be my defrag structure until I come up with something better. So this will be a vector of pairs where the left of the pair, a tuple rather than pair, the left of the tuple will be the number of blocks occupied, and the right of the pair will be the number of free blocks afterwards. The index of the vector represents the file ID. So let's implement from string for that to get it into that data structure. As always, I'll create an enum for disk defrag error, which will currently be empty, and I will also derive debug for it, so I can print it out. My type error is disk defrag error, and my function from string will return OK, disk defrag, where the pairs are an empty vector. That should compile. Now I should be able to, I can also implement on disk defrag error, on disk defrag rather, the function to complete part A. So I'll take a reference to self for that, and I'm just going to return 0. Now our do something actually becomes let defrag is disk defrag from str puzzle dot unwrap. Then our result is actually defrag dot part A. And now I can finally run a cargo test and compile all of this, and I get a 0 because that's what my part A returns directly. Okay, let's start. Let's start building this from string function. So I'm going to start by renaming this to puzzle. And then I will iterate over the characters. Kind of want to take 2 at a time. So I'm just going to use a for loop for index in 0 to puzzle.len. Can I do that? May also want to strip white space or split white space. Just want to remove it. Trim. Yeah, it's called trim. Okay, so puzzle.trim.len. Although I think I will store it in a separate variable for trim. Oh, let trimmed equals puzzle.trim. Then occupied will be trimmed index dot parse. Can I not index like that? It's a string. Cars will give me an iterator, which I don't want, unless I turn it into a vector. Now I should be able to access it. Let free is, why is that unhappy? Use of move value trimmed. I can borrow that. I'm going to get on this one because index might, because the last free space number runs off the end. So in 1, 2, 3, 4, 5, it's 1, 2, 3, 4, 5, nothing. So I don't want to run off the end of the string, so I'm going to get index dot, and I want to unwrap or, that's what I want, unwrap or 0. And then, of course, this will give me a it'll give me a character, so I'm going to need to parse it afterwards. Now I want to let mute pairs is vec pairs dot push brackets occupied and free. Then I can just return pairs. Okay, that is unhappy. Why is that unhappy? Because we need to apparently borrow this. Okay, I can borrow that. And then parse because it doesn't know how to parse a character. So it might actually be easier to keep it as a string. Let's try doing that. So let's trimmed is puzzle.trim. 0 and trim.length. We should be able to keep that and .parse it. String cannot be indexed by usize. What can I do? Can I get index and then .expect index out of bounds? String cannot be indexed by usize. Okay, so I really can't do this. I need to use a string, and I apparently can't convert a string or a character to a number. Can I do string? Wrap or dot. Okay, so I can convert it to string, so I can do that here as well. ToString.parse. For both of these, we need this. That won't be happy because it's the wrong error type. So they're both references to numbers, apparently. Can I just dereference them? Maybe. Yeah, the error is wrong. So it's a parseInt error. So I can actually just turn this into a parseInt error. Yes, yes. Then I can delete my error because I just don't need it. And that should do it. Okay. I can do a test print and see what it says it is. On my defrag. And it doesn't know how to do that because I need to derive debug on my disk defrag, and then that should be happy. It failed. We've got pairs 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. That is not right. Yeah. It's actually because we need to add 1 to this index. We're getting the next index. And also we need to increment this by 2 every time. So Rust range add, with step. That's what I want. Dot step by. Okay. So I think I surround this in brackets like that, and then I dot step by 2. So I think that should work. We've got 1, 2, 3, 4, 5, 0. Perfect. That's exactly what I wanted. Okay, so it's parsed into some data structure that I am quite likely to change. Let's start trying to write the solution. So I have an idea of what I want to do for the solution, but I don't know exactly how to implement it, because if I did, I would know the data structures that I'd want to use. So this is going to be another one of just attempting and seeing where the solution goes. Let's start. So I think I want to be able to change my pairs. So I'm going to clone the pairs that I've read out. Then I'm going to check while there's any unaccounted for blocks. So to do that, I'm going to let mute unaccounted is pairs dot iter dot map. And this is going to take a thing I don't care about and x, and I want to map to x, and then I want to sum by it. I have done that wrong. Is that better? Yes. Okay. So now, while unaccounted is greater than 0, oops, I'm going to keep an accumulator as well. Accumulator 0. And then I can return accumulator at the end. Right. Why is this not okay? Usize. I don't really mind what data type it is. X as usize. Star X. Reference of X. Consider removing it from the pattern. Okay, I'll just dereference it. That's fine. Right. While unaccounted is greater than 0, variables are not accounted for in the body. That's good. Yeah. So I am going to take from front. I might even keep a start index is 0 and end index is it would be the length of the array minus 1. So that would be pairs.length minus 1. Great. So we are going to take from the front, and how we take from the front is we take the first pair, pairs.get start index. This gives me an option, which I don't want, so I'm going to just index it. And then I'm going to, oh, that's a point. So we need to, so the index it comes from, we're currently tracking with start index and end index, but we also need the position in memory that we are currently on. This is getting to be a lot of mutable variables to track, but I think that's what I'm going to have to do. Okay, so memory index. So start pair, there'll be a left and a right. So let's actually unpack this into start occupied and start free. Then we'll use all the start occupied. That's for index in 0 to start occupied. If that's 2, then we just need to keep incrementing memory index. So this is the 0th index, so it will be start index times by memory index act plus equals. Then we need to increment the memory index plus equals 1. Okay, so that's the start occupant done. So now I want to increment 1 to the start index because that's effectively dealt with until the next iteration, although I should probably do that at the bottom. Last thing I do. Unaccounted still needs to be mutated. So we are going to unaccounted minus equals. It will be the start occupied. Okay, so that's fine. That's the front. That's the simple case. Now we need to take from the back as well. If I save this, it should be okay. Start occupant is I32. We'll just convert that to a, you know what? Let's make unaccounted a usize as well. Unaccounted an I32, which means that I don't need this. And yeah, it just becomes simpler. Right. So unaccounted is has been updated. Now we have start free blocks to take from the end. Now there's kind of 2 cases. So let's build this out as I go. End free is pairs. Pairs end index. Now the reason that I wanted to be able to mutate is because I want to track how many blocks left of the end there are. So there's 2 cases. 2 cases. 2 cases. There will never be, well, we don't need to account for the number of, we don't need to change the number of free blocks at the end. That just keeps piling up as we're going back through the array. So I want to update the end occupied. So the end occupied, it is either bigger or smaller than start free, or equal to, but that's the same as another one of the cases. So if start free greater than or equal to end occupied, then we're good. That's the simple case. We only need to take from one end block. If that's not the case, then we need to start taking from other blocks. So what I might do instead of this is account for it in a while loop, which is while start free is greater than 0. Then we're going to keep taking from the end until we filled up that amount of free blocks at the start. Okay. At which point, I should just keep looking up what the end index is. So I don't think we need to ever know what end free is. I don't think so, unless we've got some weird meeting in the middle case. But I think our unaccounted variable should account for that. So let's give it a try. Okay, so let end oc is pairs end index. Fine. Now we need to subtract 1 from start free. If end occupancy is greater than 0, then I can use it. So I'm moving from the end to the start. And it is our end index. So our accumulator plus equals our end index multiplied by our memory index. Then our memory index can plus equal 1. Our unaccounted but we also need to update our pairs index. It would be much easier if I could keep a reference to this, actually. Can I get mute index, end index? Then this returns me an option, which I will unwrap. Danger. Unwrap is okay because end index starts within range and goes down. In fact, I should just give this a better error message. End index not within bounds. Okay, so my get mute now gives me a pair. And end occupancy is now been unwrapped to unmute I32, which is good. So now I can dereference end occupancy to check if it's above 0. And then to update it, I need to end occupancy minus equal 1. Great. So that means that I don't need to do another array lookup. So while start free is greater than 0, we cannot mutate immutable variable. So what we can do here is exactly the same thing. We can get mute, start index, and we can expect start index not within bounds. There we go. Now we don't need that, and our start index needs to be dereferenced. Get mute start index 0 to start occupancy. Type usize cannot be dereferenced. Right, because that doesn't need to be dereferenced, of course. Okay, that's better. Unaccounted for needs to minus equal the contents of start occupancy's pointer. And then while start free is greater than 0, that's it. Then contents of start free minus equal 1. First borrow used here. I think it's complaining at me that I'm borrowing a mutable variable in 2 places. One to check whether it's above 0, and 1 to subtract from it. So I think it might give me an error for doing that. And I can see a red mark on the side here. I just can't figure out where it is. Pairs.getMute. Cannot borrow pairs as mutable more than once at a time. Right. Yeah, that's a problem because I do need to actually... No, I don't need to borrow it as mutable. I can copy that. So I am going to return this to how it was before. I'm going to do that. Then I don't need this. Now I don't need to dereference that, or this, or this, or this. Now we're back to the same problem that we were before, which is that we can't mutate this, which is fine because now we can turn it into a mutable version of itself. Which this should copy it, which is why this is allowed to convert it to mutable. It's not taking an immutable object and making it mutable. It's copying an immutable object and making it mutable. So now I can do this, which is perfectly allowed. All right, so that is Rust's borrow checker, making sure I'm not mutating a vector in 2 places at the same time and potentially shooting myself in the foot. Let's space this out a little. Okay, so while start free is greater than 1, that's fine. Otherwise, if we run out of occupied spaces at the end, then we need to remove 1 from end index. So end index minus equals 1. And then we don't want to remove 1 from start free because we've not used it. So what we're actually going to do is move this to here. And this blocks in 1. Okay. This, I think, makes more sense to increment once we've just used it. And then unaccounted doesn't change for this. So we actually do need to unaccounted minus equals start free. All right. This actually, I think, is all of it. So let's give it a try. Failed. Why? Because index out of bounds, the length is 3, but the index is 3, and this is at line 34. Okay, that's not good. Some debugging to go on here. Start index should have never reached the end. So I'm going to print line start awk and start free. I'm also going to print out my unaccounted for. Wait, my unaccounted, I'm summing the free spaces. Is that true? I need to account for the occupied spaces, not the free spaces. Let's try it again with that change, and it's still wrong. Okay, that's fine. In the same way, good, right. So it's 1, 2, 3, 4, 0, 0. It should be 5, 0 to begin with, because we can see this printout here has 5, 0. So why is that not the case? Start awk, start free. And then we should print unaccounted on every change, I think. Okay, unaccounted after the start block and after unoccupied. That seems odd that it's just giving me 8 in both cases. The start arc start free is 1 and 2. Then my accumulator gets that. My unaccounted minus equals start occupied. So at this point, it should be 7. I feel like that's fairly simple code. I mean, we're printing out start arc is 1. We did unaccounted minus equals start arc and then printed out unaccounted. And it's the same. So we've not subtracted 1 from unaccounted. Actually, so the reason that this is 0 instead of 5 is because we've been subtracting from it. That makes sense. We've taken 5 off it. That still doesn't explain why the unaccounted variable isn't updating. Okay, I don't know why that is failing. I've moved it to a different way of doing it. Hopefully that gives me better numbers. Right. So that's better, right? That's giving me 69, which is a weird number, but... So unaccounted after start block is still 8. This is where a debugger would come in really handy. Fortunately, I don't have one set up, but it would be nice to get that set up. So let me see if I can do that quickly. Extid because I don't have a breakpoint. But actually, it is set up. So let me break here. And then debug again. Debug. Splat. All right, so unaccounted is 9. And unaccounted is 9 because it's 1, 2, 3, 4, 5. 1, 3, and 5. 4 and 5 is 9. So we need to account for 9 blocks. Maybe that's where my calculation is going wrong. This is 1, 2, 3, 4, 5, 6, 7, 8, 9. No, that is right. That's 9 unaccounted blocks of space. So fine. Start awk and start free, 1 and 2. Accumulator is start index times memory index. but memory index is 0, so that gives me nothing. Memory index plus equals 1, good. Unaccounted minus equals 1. Unaccounted is now 8, right? So it was 8 because it started at 9 and it got 1 subtracted. So that's the problem, it is actually doing what it's meant to be. Start index plus 1. The next iteration of this loop, we're going to start looking at start index minus 1. Start index plus 1. Okay. Start free is there, while start free is greater than 0, so this is 2. So my end occupancy is this. We have 5, which means we can take all of this free block, we can pull it completely from the end. It is above 0, so we're going to increment it by end index, which is 0, 1, 2. Yeah, that makes sense. That's the file ID. And then memory index is 1 because we're in the 1th slot. So yeah, that's right. Accumulator should be 2. So to show you this down here, we've taken a 2 from the end and moved it to the start. It's in index 1, file ID 2. So that is plus 2. Memory index plus equals 1, that's right. End occupancy minus equals 1, there's 1 less 2 to take from the end block. Start free minus equals 1, there's 1 less unoccupied block at the start to care about. Unaccounted for minus equals 1, because we have accounted for an extra block of memory. Great. So that's fine. Now we're going to go through it again because start free is still above 0. We do all the same things. And that's it after one loop. So now our unaccounted block is 6. I think perhaps if we do a check, if unaccounted less than or equal to 0, then break. And I can repeat this because we're changing it in 2 places. We can actually get to -1 on unaccounted, which is not what we want. Let's try running that just as cargo test. And that actually gave me the right answer. Okay, so I actually solved the very small test case. Let's repeat this with the actual test case that it gives us, the moderately sized one. So we're going to take from test.text. I don't need to print line this. And my result has nothing to do with these commented lines. My result should be 1928. I will be very impressed if this works. Let's find out. Failed. There we go. Did it panic or... We got to -1 again. I wonder if we need to... We should never get below 0. That's the interesting thing. So unaccounted after start unoccupied, 1. Then we check unaccounted here. If unaccounted is less than or equal to 0, then break. So this should just stop where it is. And we are getting a value that is too large, right? It should be 1928, and instead we're getting 2096. We can check if it's equal to 0, but less than or equal should be a better check than that, unless there's another place that unaccounted is being mutated. Unaccounted, unaccounted. No, that should be it. So I really don't understand how it's getting below 0 here. That was the same code. I don't know why I expected a difference. So unaccounted after start block is 0. So why did this... Oh, it's because it broke out of the for loop, not out of the while loop. I think I can tag loops like this. And then when I break outer. Yeah, and I can do the same thing down here, outer. Okay, that's the right answer. Interesting. I can get rid of this. It makes me think I've got warnings where I don't. And the only warnings here are my unused variables. That's cool. All right, so let's try it on the real thing. Let puzzle is include string // puzzle / test.text. I'll change this to input in a second. I just don't want the compile error from it. That defrag is the disk defrag from str puzzle. And this can give me an error message, so unable to parse input. And then print line part A is defrag dot part A. Run that. That should give me 1928. Yes, let's get rid of all these print lines because the real case is much, much bigger, and I don't want print lines slowing it down for no reason. We can get rid of this and this. Get rid of this, and that's it. Run it again. That's it. Good. Oh, we don't need hello world as well. Let's get rid of that. Run. Okay, let's get the puzzle input. Now, there is a warning about how long this puzzle input is. And be careful to copy and paste it. So I'm going to check that the first few digits after I've pasted are 8395 and the last few are 5274. So let's take our input.text. Is that what I normally call it? I'll do. Okay, so it starts with 5370. Oh, it starts with 8395, so that is right. And then the end is 5274. 5274. Okay, so it did copy it correctly. So let's change this to our input.text and run it. And it worked very, very quickly. Okay, normally when you see a massive input like that from Advent of Code, you just know that it's going to take way longer and you need to rewrite your algorithm, or at least I do. But in that case, surprisingly, it did calculate immediately and was correct. So hey, let's continue to part 2 and check how much time I have left. So I'm going to read through part 2 and see what the puzzle is about. Okay, this is a pretty interesting extension. In one sense, it's easier because I don't have to do for loops doing individual variables. On the other hand, I'm getting ahead of myself. Let me explain. So instead of copying bytes over, we're now copying entire files. So we start off with 0, 0, and then we get 3 free spaces. So we want to copy the entire file of 9s over. So great, we can do that. We continue as before. However, once we get to here, we've got 3 free spaces. We can't fit the 8s in. There's too many of them. We can fit the 7s in. So it's easier in that you can copy chunks of memory instead, and harder in that you can't just take the end one and expect that to be enough. You have to search back from the end until you find a set of bytes that is small enough. I think that sounds pretty interesting to code. So let's start by setting up a new test case for it. So I'm going to grab this test, rename this one to part A, and this one to part B. I'm interested to see if this small use case actually has enough. And this isn't a good test case. There's nothing you can copy, so we don't want to repeat this test case. We'll go straight to the bigger test case. Okay, so we're going to now instead run part B, which should give us 2 858s. Good, right. We need a part B function. This function got complicated. That's fine though, that's fine. Okay, So we're going to go through the same stages. Are you unhappy about something? Defrag.part B, yes. I'm not sure why that said I32. Anyway, that's fine. Part B. Now, we can't just keep track of the end index. I was thinking that I could delete the nodes, delete the files from the end of pairs as they're copied over. But if you delete one that's not at the end, then you're changing the index, the file index, right? So I wonder if I should be hash mapping it with the index. Because then once I've deleted it, I can just go back. That might be the best thing to do. All right, so in this case, I am going to take self.iter.enumerate. I'm going to keep a hash map. It will figure out in a moment what's going into it. So for in, this will be our index and our pair. Then we will insert index and our pair. With that, we don't need pairs anymore. Our unaccounted will be the same, actually. It will be our file map, although we can just use self.pairs. Yeah, instead of iterating over the values of a hash map, we already have a vector prepared. Let's just use that. Our end index, I don't think we want to track this anymore. Maybe we do so that we know what the maximum is. Okay. At which point, I know it's self.pairs.length. Instead of calculating it from the hash map, again, I have the vector that I can just take the length of. Our memory index is still the same, so that's fine. Now, we're now going to have our file index is 0. I think our start index is the same as our file index, though. Maybe I don't need this. File.map get start index. Dot expect start index not found. That's fine. So because it's at the start, the behavior is identical. Now, when we get to how to fill the missing spaces, that's where it starts to change. So I don't think we'll need a while loop for start free anymore. I think we might be better off just removing all of this. It'll be interesting what the termination condition is as well. Okay. We need to find a block moving from the end backwards that is small enough to fit inside our number of free spaces. we also need to check that we're not going past what the start index is, because then we're copying a block of memory from earlier in the text to later, which is wrong. We also, once we've found a block from the end that we've copied over, we want to delete it. So let's see how to do that. So we can actually say for end index in let's say for index in end index down to 0. I think that's okay. Can I do Rust iterate backwards over range? Range and reverse range. That's what I think would be good. .rev. I thought there might be something better than that, but I guess there's not. Okay, that's fine. So we're going from start index to end index, including end index. And we're reversing it. Okay, great. So now we want to check if memory block exists, because we may have deleted it, already. So I'm wondering if let is better than this, but maybe I'm getting ahead of myself. Let's do a let, or even just keep it simple. If our file map does not contain the key of index, then continue. And I think we may need to borrow this. Yeah. Okay, great. If it doesn't have the key, we're going to continue checking. If it does contain the key, then we need to get the insides. So we'll do, we will use this, so I'm not too worried about that. Let, probably true that this isn't mutable though. Keep getting distracted. Right, let the end occupied and end free is equal to file map dot get. We may even want to, no, we don't want to get mute, we'll just delete it afterwards. Okay, so we're going to get the index. And we can actually just unwrap this because we've already checked if the key is contained here. So I'll do that. Now, I don't actually want the end free. I don't care. So I'm going to change this to an underscore. Now, if our end occupancy is less than the start free, then we're just going to continue. It's too big. Sorry, if end occupancy is too big, then continue. However, if we get to this point, then we found a block of memory from the end that we can copy to the start. Let's do the copy and then the delete. Copy memory over, delete memory from end. Right. Ooh, I wonder if we need to fit the biggest file possible. No, because if we did, we would have copied 7s here, not 9s. That makes it easier, right? Let's do the copy memory over first. For loop on the end occupancy. I'm still doing this for loop, by the way, because it is really useful to check if the unaccounted has changed mid-loop. Memory index +1, unaccounted minus or less than equal to 0, that's fine. Now this is wrong. This should in fact be our current index times memory index. I think that's okay. Then we need to delete the memory from the end. So now we need to file map dot delete. Clear contains key, drain, no. Intermute length, remove. We need to. In fact, we can just do this in one step. When we file.get, if we remove, gives us just the value. So let's just remove. Now it's deleted already. So we're done. I feel like that was very simple, and I doubt that I did it correctly. But let's do a test and see how badly broken it is. Failed, start index not found. Pardon? What? Do we just fail immediately? Let's debug this test. Part B. Give me this file map. In fact, give it to me after it's been constructed. Debug. Okay, unaccounted gives me. Wait, file map is. The 0th slot is 23. Is that what we expect? 23. Yes, it is. Great. Let mute unaccounted. Fine. I don't know why it's upset, so I'm just going to play until the next breakpoint. Unaccounted is now 28. All right. I'm going to assume that's right instead of counting. Accumulator. Okay, while unaccounted is greater than 0. Okay, so we do get the 0th entry. Of course. If we take from somewhat the middle, then when the start index gets there, it won't be found. Okay, that's fine. So let's if file map dot contains key start index, but it doesn't contain the key. If it doesn't contain the key, then increment start index and continue. Now this might run off the end. In fact, it might create an infinite loop. So if start index is greater than end index, panic. Panic! Start index exceeds end index. This would just bring the whole program crashing down. And we got that exact panic. Okay. This is proving to be a bit tricky. So I think there's some error in how I've done the accounting of memory. It would be nice if I could construct a smaller use case to test against. If I did 5, 4, 3, 2, 1, that should generate 1, 2, 3, 4, 5, 1, 2, 3, 4, 1, 2, 3, 1, 2, 1. Now if I get this, I should copy 2 and then 1s. So this would actually become 1, 2, 3, 4, 5, 2, 1, 1, 1. This is 0, 1, 2, 3, 4. That'd be 5 times 2, 6 times 1, 7, 8. So that becomes 16, 23, 31, I believe. Let's do that. Test small rev text. I'm going to take this and copy it to here. Okay, we're going to test small rev. We are going to do a part B on it. We don't need to print this out, and the result should be 31. Let's get rid of this for now, and then cargo test. So we get all passes. Oh, I wasn't expecting that. Okay, so it did it right. It does it right for a very small use case, but not for a medium use case. That's very odd. I guess there's something I've done wrong with this. The start index to exceed end index, it needs to have run off the end of the file map. So unaccounted is not good. Do you know, I don't think we account for the point where start index plus equals 1. So we're already going on to the next block. If we don't fill this block, this for loop just exits. Let mute memory copied equals false. Memory copied is true. And if memory copied, then memory index plus equals start free. As long as we haven't changed start free in that block. No. Okay, so that was the case where if it didn't find something to put into that block. Oh yeah, memory index. Memory index. If it didn't find memory from the end to put into that block, it should still increment the memory index to get the right answer. Now that is something that was missing. That's something that was missing, but it doesn't explain why unaccounted isn't being taken down to 0. That would have it would have completed successfully and given me the wrong answer if that was the issue. So let's keep searching through this. That's something interesting that what I'm doing doesn't account for. There's an empty memory block left by the missing or the deleted memory. Variable is optimized away. Uh-oh. Well, it should be up to 9. What's end index? 9. Yep. And occupied is... Oh no, we're removing it. Ah. Okay, we can't do that. We have to get it. Got unwrap. We can unwrap there. And then we can delete it if and only if it has proven to be small enough to copy over. Delete copied memory. Now, I'm just hoping to get rid of the unaccounted issue. If that works, then I'll work on making the continuous blocks of memory work. Okay, so delete copied memory. Check. File map dot remove and index. That should be it. Okay, let's cargo test it. It gives me the wrong result. It gives me a result that is too small, which makes sense because I'm not accounting for that missing memory. So that's good. So what I can now do is let mute copied memory is a hash set. That's just to make the lookup a bit quicker. Type annotations needed. You'll get them. You'll get them. Now, if our start index is contained within copied memory, if copied memory dot contains start index, then we need to copy the blank spaces. So the blank spaces should be accounted for down here. Let me explain what I mean a bit better. So let's say we got to here. We have 333 and then a blank space. So this blank space is accounted for by this if memory copied, because there's one free space, nothing fit in it. So we've incremented the memory index, but we've not added on to the accumulator. However, now we have two blank spaces that should have been left by the fours. So instead of removing it from the file map, I'm now going to insert it into copied memory. Copied memory dot insert index. Now there's two places we need to check. We need to check that if copied memory dot contains the index, then continue. And that is replacing our check whether it contains the key or not. Okay, so if we've already copied it, we can't copy it again. If the copied memory contains the start index, then we need to account for, we can do start. Actually, we don't care about occupied, but we do care about free, is the file map.get, and it'll be the key, which is index. No, it's not, it's start index and start index. So memory index plus equals free. And then we continue. Unwrap. I think unwrapping is okay there. It might go off the end. So let's say expect start index out of bounds. Copy memory.contain start index. We can check that. Memory index. Start index is usize. Memory index should also be a usize. Why is memory index not a usize? As usize. That's because the first use of memory index was adding on an I32. So it assumed it was an I32, but changing it to a usize solved more problems. Okay, let's see if that accounting... Nope, that accounting has now implemented an infinite loop. Great, so We are continuing instead of incrementing start index. Try that. Failed because of too large a result this time. Okay, interesting. We're getting closer. I actually wonder with this copied memory whether we even need a file map anymore. I think we can just use the vector as it is. That might be a good refactor, but it won't change anything in terms of correctness of results. So I won't do it for now. I may do it in a quick tidy later before committing. So what is the problem here? I wonder if our last... Can we print out the accumulator every time we add on to it and see if we get the correct answer? Because that would imply that we're just going by one too far. That's one accumulator and another accumulator. Oh, wait. There we go. Let's try doing that. I'll go test. And we get... It completely misses it. Right. So we are calculating wrong. Let's see what's happening. So this should be like this. So we get 0, 0, 2 times 9, 3 times 9, which is 27, add 18 is 45. Then we should get, oops. I'm sorry, it's got 2 as well. Okay, that is really interesting. So that means that I have misunderstood how to do the problem. It's not just one attempt at a copy if the file is small enough. It's multiple attempts at copying until there's no more free spaces left. Right. That can be accounted for. While start free greater than 0. End occupied, sorry, if copied memory contains, continue, go to the next loop, fine. If end occupied is greater than start free, then it's too big to copy, so continue, fine. Now we're going to copy some memory, good. Then once we've copied the memory, we actually want to update start free to minus equal the free spaces, which is end occupied. End occupied. Doesn't like that. Cannot assign to start free, which is bind a and reference. Yeah, that's fair enough. Let mute start free equals start free. I'm going to shadow the variable with a mutable version, and then we don't need to do that. Start free just becomes start free minus equal end occupied. And then if memory copied, what did I do here? So if I did copy some memory, then my memory index has already been incremented. So this should be if not memory occupied, then we add the remaining bytes that we've not accounted for to the memory index and break. Now we're too small again. Okay, well, start free greater than 0. we check if we copy any memory. We search the memory. If we've already copied it, we're not going to copy it again. If it's too big, we're not going to copy it again. Actually, what do we... So we're searching. If it's too big, fine. If we get to a point where we don't actually want to include start index, I don't think. Because then we're copying our current bytes to our current bytes. So I think this should be +1. I don't know if that changes anything significant. I think it's more correct. Oh, it breaks it. Okay, let's reset that. Test small rev text becomes wrong. Test text part B becomes wrong. But the other two are okay. Yeah, because only this. Are we sure about test small rev text? I'm just going to check my maths on this. So test small rev text is 5. And then 4 free spaces. 1, 2, 3, 4, 5. 4 free spaces. 3 occupied spaces. 2 unoccupied spaces. 1. So we move the 2. And we move the 1s. And these are replaced with dots. And a dot. That is correct. And then it becomes 0, 1, 2, 3, 4, 5 times 2 plus 6 times 1 plus 7 times 1 plus 8 times 1. And then it's 16, 23, 31. So yeah, the math is right, which means that we do want to keep that as it is. Fine. So where was I going with that? So we're checking the index in that for loop. If the copied memory contains it, as in we've already copied it, skip it. We can't do it again. If already copied, skip. If too big, then skip. We're keeping searching. At this point, we have found something that can fit because we wouldn't be in the for loop if the index was wrong. Oh, right. The reason that we don't add 1 to this is because we've already added 1 here. That actually makes it easier. Makes it a bit confusing why that happens, but yeah, we don't have to add 1 in the range. So that's fine. And then we're already checking here, and then we increment 1. Yeah, so that works. All right. That index out of bounds. Check memory has not been deleted. This should not happen because memory doesn't get deleted. So I don't think we actually need that anymore. That makes it slightly simpler. It's just, yeah, good. Take from front for start paces occupied. Yep. Maybe what I can do is check the accumulation. Come on. So I can take this and put it here. And then I can also create just a small block of text. Test ack. I don't know. Something simple. Now we want this. Let mute ac is 0. For c in input.cars, if c dot is digit 10, ac plus equals c dot to integer, the string dot parse dot unwrap. Index c and dot enumerate index times, and then print line. Run that test. Cannot infer type, accumulator. What's index? Why is this not allowed? An I32. Is that okay? No, because as I32. Fine. Is that okay? No. As I32. Okay, that's okay. Right. Try is ASCII digit. Fine. Run it again. And then I get the accumulator. Let's see where I differ. Actually, I can have it here. Right, so it's 45, 53, 58, 64, 71. All seems to be... Oh no, here we go. 127, 190, 260, 308 versus 302. Okay, so 308 versus 302. Let's work out where in the string that happens. That implies that the memory index is too small. So we've got the two 9s. We've got the 2, 1, 1, 1, 7, 7, 7, and then there's a dot, right? So I think the true program has accounted for the dot, and my program hasn't accounted for the dot. Now, why has the dot appeared? The dot has appeared because it couldn't copy anything into that space. It was too small. So that's what I'm expecting my copied memory to account for. If not memory copied, let's debug and see what's happening here. Bug. All right, start free is 1. So memory index plus equals 1. And then we break the while loop. And we should go to the top. Okay, so here we're saying memory index is 17 and going to 18. Does that match? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's 10 going to 11. So the first time this memory copied works in my program is too late. I'll make a note of this. 10 to 11. Should be 10 to 11. I get 17 to 18 first. Right. Okay, so why is that the case? We are searching. If we get past this for loop and we haven't found a file to copy over, which should be the case because start free is greater than 0, start free is 1. Unless we've not updated that properly. So let's see where we're updating start free. Start free minus equals contents of end occupied, because we've copied all of those, right? Let's just go through this loop and see what it's doing. Okay, so memory copied is false, right? The index. So we're copying some memory. Let's continue until the next iteration. Copied memory, that's already been copied. So copied memory currently contains 2 and 9. I don't know if that's right. It's 2 and 9. Yeah, so it's filled this slot. Filled this up completely, which is correct. So then it should have done 1s. What's start index at the moment? It's 2. Yeah, so it's just done 1s, and now it's trying to fill in the 7s. So index is currently 8. So we're checking file ID 8, which should be too big. It is. Now we're checking 7. It's not been copied. It's not too big, so we copy it. Let's just run to here. Okay, great. So our memory index is now 11. I might have been off by 1 when I counted this, I guess. Start free should be 3? No. I don't think that's right. So we're down here. We copy 3 7s. The freeze should be 4, not 7. Let's repeat this. Let's repeat this and make sure I got it right. So first up, our start index is 1. So we're going to continue on. Okay, now our start index is 2. Did I just skip past it? That's 0, that's 1, and then that's 2. Yeah, so I did just skip past it. Okay. Okay, start index is 1. No, I do want start index to be 2. Skip until start index is 2. Right, that's correct. Memory copied is false. Start free is 3. Why is start free 3? Start 3 should be 4. But it's not 4. And it's not 4 because we've copied the 2. Oh no. What's happening is we are copying. No, that's fine. Start free is 3. So start index is 2. Our start free is currently 3. We want to copy the 7s into it. And then it's the existing 2. But then we're copying our 2 earlier into the system. Why are we doing that? I guess it's because it's doing multiple stages for what I'm trying to do in one stage. So it's copied to, so this might be an order of operations thing. So start free is 3. We're going to copy 7 into it. It should have no free spaces after it. I think what happens is this has been copied, so we need to account for that, right? Which I think we have code for. That is if the copied memory contains. So we're getting the start index, which is 2. That should give me a... right. I think we actually want to count the occupied spaces from this, because that's how many free spaces there now are. Two has been copied out of it, and now there's 4. Let's try doing that. It failed. It's given me an even smaller result. Is this now more correct than it was before? I think it's worse than it was before, technically. Let's just run this test. And then do a full cargo test. Cargo test. Where do we divert? So the correct has 53, 58, 64, 71, 127, 190, 260. And then mine has 296. So it's adding on too small a number. At what point is it adding on too small a number? This is mine, right? Yeah. So 296 shouldn't be there. So zeros, 9s. The 2 takes it to 53. 1, 1, 1. 7, 7, 7. There should be a dot which increments the memory index, and then the 4. And this dot is where 2 used to be. Let me debug and see if I can see that happening. Maybe I need to take... do I still need to fill up the free spaces in front of 2? I do. I do need to fill up the spaces in front of 2, because that copies the 4. But if I've already copied the 2, then I'm not trying to fill up the spaces in front of the 2. So actually what I need to do is add on to the memory index if the occupied bytes have been copied, but I still need to try and do the free section. Okay, so this should get to the free section, right? We can get the start occupied, then check if it's contained in the start index. If it is, we don't need to continue. We move on to this bit. In both cases, start index is incremented. So we can remove that. So either it's free space and we just increment the memory index, or it's the bytes are still there, so we add them on. Okay. That gives me the right result, which I'm a little shocked at. But let's run it for real and see if we get the right answer. My file's gotten so cluttered I've lost my main function. I'm sure there's a lot of refactoring that can be done in this function, but given how much time I've used already, I'm going to be leaving it pretty messy and just moving on. So cargo run. We could have gotten rid of those print statements to speed it up a bit. In fact, I think that's probably still worth doing. Let's do that. Print line accumulator, print line accumulator. That's fine, and that's fine. All right, let's try that again. Cargo run. We are running for a long time. So I guess what I've done is maybe it's building this hash map. It did give me a result in the end. Let's try the result. That is the right answer. Okay, we've completed day 9. It's horrible, but it does work. I'm wondering if I can just get by without this. I can. It seems to take roughly the same amount of time anyway, but I think because it's simpler, I will change it over. So that refactoring to remove the hash map didn't take long at all. I'm going to take out this commented code. Oops. And with that, I have completed day 9 of Advent of Code. That was a really tricky one. I think there were lots of little nuances to copying the files over that I didn't account for the first time around, and it took me quite a lot of time, unit tests, and debugging to get it right. But that's actually given me all the more satisfaction from having completed it and gotten the right answer. So thank you for watching. I'll be back tomorrow with day 10, and we'll see if we can get that finished in one video as well. I'll see you then.